So let's try and identify the different types of energy that we see in all of these questions. First thing we want to address are the four different answers that they could possibly be. So you have kinetic energy, which is the energy of movement, right? So this is the one we see most often. This is why windmills turn. We take the kinetic energy of the wind. It's why you run. It's considered kinetic motion. It's the most obvious one that we see. Then you have potential energy, and this one is kind of a tricky one at times, but we do see it quite often, and it's stored energy. And sometimes when we think of stored energy, we'll think of like batteries, which is certainly true. Batteries, in a certain sense, are certainly potential energy. But also, if you have the classic example is if you have a ball on top of a hill, it has the potential to go down and start moving with kinetic motion. But before all that movement occurs, it has the potential to move. Therefore, potential energy can also be seen as something resting on top of a hill, or as something that's ready to fall down, or anything that's ready to be moved on its own or through its own kinetic means. Then there's chemical energy. Chemical energy, this one's harder to identify, especially if you're not familiar with things in chemistry, but it's the breaking of bonds typically that we get after you light it on fire or you separate it one way or another. So a very extreme form of chemical energy could be like the atomic bomb, or nuclear fusion, things that go on. But that's beyond the scope of what we're doing here. But the most common example is when you burn wood or if you digest food. In food, there's energy in that, but it's kind of locked away in all these bonds. So what your stomach literally does is rip it apart and releases energy that's typically holding things together and uses that same energy for other things. And then there's the one that we see most often in our day-to-day lives outside of kinetic, and this is electrical energy. This is when we see the transfer of electrons. This is pretty much anything that moves a motor, or anything that is you kind of consider technology, I guess, would be a way to consider electrical. So let's go through these answers. Remember, you want to pause, try and answer them first on your own, and then see if our answers match up. So Carl's stomach breaks down the food in his stomach to release its energy. That energy is then transferred from his stomach to the muscle in his legs that ran for a touchdown. So the food actually breaking down, as I mentioned earlier, that is an example of chemical energy. And then when his legs are actually running, going for the touchdown in the actual process of movement, we're going to call that kinetic energy. All right, number 2, Jessica throws a ball at a light switch to turn on a fan. So go ahead and pause it if you haven't already to see if you can match up your answers. The actual ball throw itself, we're seeing that this ball is moving from point A to point B. It's moving. So that once again tells us that it is kinetic energy. And then the fan turning on. Well, what turns on a fan, right? All fans are typically powered by electrical means. So it's in this case that we're going to call this electrical energy. This is when the fan actually turns because electrons are flowing through it like water through a windmill, or water through a watermill, and that actually causes the movement. Number 3, battery that has been waiting inside of an iPhone is finally activated to illuminate the screen. I like this question because a lot of teachers that teach science will kind of expect you to get all elements of this. So I really want to break it down. Battery. What is the battery? Well, there are 2 forms of energy that when we think of batteries, because there's stored energy, we're going to call this potential, right? But also, how is it stored? Are batteries like wheels that are on top of a hill, right? Are they like just waiting to be thrown down or anything like that? That's not the type of energy that they're storing. This energy that they actually store is stored within acids and bases, and it's actually considered to be a chemical storage or chemical energy. So there are some teachers that would consider both of these answers to be true, depending on how far in depth they want you to go. Then the lighting of the screen, that's going to be a very obvious electrical. It's a very electrical form of energy. Number 4, a basketball is placed on the highest point of a building downtown, and it is then thrown down to make the most amazing trick shot ever in just one try, right? We all see those videos. We know they take more than one shot, but imagine if it goes through. Ball waiting on top of building. I hope at this point we have become familiar with that being potential. And then ball traveling through through the hoop. All right, that actual traveling, that movement through the hoop, we're going to consider that kinetic energy. Okay, so I just want to get a hold of the last question here. That's going to be number 5. I couldn't fit that on the original score there. So a battery powers Mark's favorite drone to fly up to 500 feet in the sky. That drone stays at a high elevation taking pics until it is hit by a slingshot ball. His favorite drone then crashes to the ground, causing it to catch fire and burn for 7 minutes. The time isn't relevant. The fact that it's his favorite isn't relevant. I just wanted to add some compelling storyline. So I like this question. If you see there's 4 options, just tell us that ultimately we're going to use all 4 forms of energy. It's just a matter of properly identifying it. Battery powering the drone. That is going to be our electrical form, right? Because it's a battery powering the drone. We all know that these things are electronic devices. Drone staying above at 500 feet above the ground. We actually happen to know that that's going to be potential, right? Because it's waiting above the sky. If this is the ground, right? And here's your drone, right? I can't draw wings, so I'm just going to draw these wings, right? It has the potential to move downwards no matter whether you have it on or off, right? You can just turn off the drone and it's naturally going to move, right, towards the bottom. So before it starts its movement downwards, that means it has the potential to move there. Therefore, it's sitting up there in the sky is considered potential energy. A slingshot ball flying towards a drone, that is telling us that it's kinetic. All right, kinetic energy because we see that the ball is flying, moving towards our object, and then the drone burning on the ground, that is our chemical. Anytime you see something burning, just consider that to be a chemical, it's a chemical change, but it's also a chemical form of energy.